So what if I told you that the universe isn't made of permanent, tiny little billiard balls? What if instead it's more like a giant cosmic Lego set? A set where the pieces themselves can just appear and disappear on command. Well, today we're going to dive into the two most powerful tools in all of physics that do exactly that, the creation and annihilation operators.
In our everyday world, things are pretty simple. If you have 5 apples, you have 5 apples. But the quantum world, it throws that rule right out the window. Think about it. A hot piece of metal starts glowing. That's it creating photons, particles of light that weren't there a second ago. Or an electron can meet its opposite, a positron, and they both just vanish in a flash of energy. So how on earth do you keep track of anything when your particles can literally pop in and out of existence?
All right, here's how we're going to break it all down. First, we'll tackle this core problem of changing particle numbers. Then, we'll meet the super elegant tools physicists came up with to solve it. We'll find out that these tools act differently depending on whether a particle is sociable or kind of antisocial. And then, for the grand finale, we'll see how you can build an entire world from absolutely nothing. And finally, we'll understand why this isn't just some math trick. It's the fundamental language of reality itself.
Okay, so let's get right into it. The old rules of physics just don't cut it here. When the number of players on the field can change at any moment, you need a completely new playbook.
Yeah, see, the problem is that to describe these systems where particles come and go, you need a new mathematical framework. You can't have one set of rules for a one-particle system and a totally different set for a 10-particle system. You need one big master rule book that can handle any number of particles. And, this is the crucial part, a rule book that can handle the jumps between those numbers.
So, what's the fix? How do you build a system that's so flexible? Well, physicists came up with this really elegant and powerful solution. Two special operators that act kind of like cosmic construction workers. First up, meet the creation operator. You'll often see it written as a dagger. Just think of it as the universe's official giver. It has one job and one job only, to add a single particle to whatever quantum system you point it at. It's the tool that builds things up.
And of course, for every builder, you need a demolisher. That's the annihilation operator, just written as A. It's the taker. Its job is to reach into the system and remove one particle. Simple as that. So together, these two operators are the complete toolkit you need to manage all the particles in the universe.
And this isn't just some vague idea. I mean, look, these operators follow really strict, predictable mathematical rules. Now, don't worry about understanding all the math here. The big idea is that these formulas are basically the instruction manual for our cosmic Lego set. They tell you exactly what happens with total precision when you create or destroy a particle.
But here's where it gets really interesting. The rules of the game actually change depending on what kind of particle you're dealing with. It turns out particles have, well, they have personalities.
Right, so on one side you've got bosons, like photons. These are the socialites of the universe. They have zero problem piling into the exact same quantum state together. In fact, they love to bunch up. But on the other side you have fermions, like the electrons in your atoms. These guys are the ultimate individualists. They live by something called the Pauli exclusion principle, which basically says no two of us can ever be in the exact same state at the same time. And this fundamental difference in personality is why the rules for creating and destroying them are just a little bit different.
Okay, we have our tools, create and annihilate. We know the rules for the different types of particles. Now, for the truly mind-bending part. Let's see how these simple tools can build everything we see, starting from the most profound emptiness you can possibly imagine.
So first, we need a starting point, right? A blank canvas. In quantum field theory, this is called the vacuum state. It's not just empty space. It's the state of pure absolute nothingness with zero particles in it. But it's a nothingness that is just brimming with potential. And this diagram here illustrates the whole process perfectly. This is called the Fock basis. A great way to think about it is like a ladder of reality. At the very, very bottom is the vacuum. That's our nothingness. And every single step you take up that ladder is a different state of the universe, built by adding particles to that vacuum. You've got your one-particle states, your two-particle states, and on and on and on. All of it just built up from nothing. So let's actually walk up that ladder. We start at the bottom, the vacuum state. No particles, no energy, no thing, just pure potential.
Now we take our creation operator, our little building tool, and we use it on that nothingness. And poof, just like that, a particle appears out of thin air. We've literally just created something from nothing. We now have a one-particle state.
Want to build something more complicated? Easy. We just apply the creation operator again. Bam! Now we have a two-particle state. You can keep doing this over and over. By repeatedly using this one simple tool on the vacuum, we can construct any state with any number of particles we want. We're literally building reality one quantum at a time.
So we've seen how it all works, but the biggest question is, why does this matter so much? Well, this isn't just some clever accounting trick for particles. This whole concept is so fundamental that it becomes the very language physicists use to describe the universe.
And this quote right here says it all. It's so important. It says that all operators can be expressed in terms of the creation and annihilation operators. What does that mean in plain English? It means that everything you might want to measure about a system, its energy, its momentum, where it is, all of it can be described using combinations of just these two basic actions, adding a particle and removing a particle. It's like the alphabet of quantum mechanics. And that brings us to one final really deep thought. If every possible state of our universe, from a single speck of light to an entire galaxy, can just be described as a sequence of creation tools acting on a state of pure nothing, then what does it even mean for something to be real? Maybe something is just an excitation of nothing, a beautiful, complex pattern written on the canvas of the void. What do you think?